Hi there. I'm going to start because otherwise we're going to run into lunchtime, and I don't want you to be hungry. Hi there. My name is Farmar. I work for a particular software. We build end service bus, and I'm a solution architect. Basically, I work with customers to help them solve their architectural problems and get them going on the right direction when going about building a distributed system using messaging. I've been in the industry for about 20 odd years, about 94. Before that, I was a sound engineer for 12 years. And my first experience with code was to do multimedia. Anybody did multimedia here? I am ancient, right? Yeah, seriously. So I started with kind of doing discs, titles for multimedia, and then the internet came along. And I've been doing that since then. And about 2007-08, I realized that the way we build system is not really working. And I kind of stumbled upon the whole concept of service-oriented architecture and started working with end service bus. It was version 1.6 or something like that. And ever since then, I've been doing service-oriented architecture, now called microservices, or whatever you want to call it. It's the next thing. So I think that most of us have been there. We all come into this new greenfield project. We are the Tiger team. We build this, we design this new thing, and we have a lot of knowledge of the domain. We put the designs in place. The code looks absolutely amazing. We know the domain, we know the code. It runs perfect, there's no problems. Then, the business succeeds hopefully, and we go to the next level. And it happened to me more than once that I was still around when, we went for version 2 and version 3 and so on. And at that stage, things get really kind of interesting. We start adding features. The beautiful design that we started off with kind of works, but actually it doesn't really work. And we start adding, the design becomes a bit of a problem. And we start messing it, and we start hacking it, and and more developers come on board, and they don't really know what the design was all about, and they go ahead and hack the hack, and and then they can't really hack the hack anymore, so they just write their own class to do the same thing over here, and then, the thing scales, so there's a lot of business, there's more people, and the business goes, let's add just more developers, right? If we add more developers, there'll be more productivity, right? And that works really well, doesn't it? No, it doesn't. It just makes everything a lot slower and a lot more complicated. And then we get to this point where the project manager comes, as soon as the project manager comes into the room or to your space or sends an email about a change request, everybody disappears. It's just like, I'm not going to fix this. No, I'm not changing anything in this code base. And every time we deploy this monster, it takes like 3 to 4 attempts to actually deploy it, and afterwards another 3 or 4 attempts to stabilize it. And then a couple of months later, it fails again, right? It just blows up because there's a peak or whatever. And that keeps happening again and again. And we end up with this big, huge ball of mud. Anyone been there? Am I the only one? I'm sorry, the lights are in my eyes. It's horrible. Can't really see you. And there's even a pattern in software engineering to describe this thing, right? So it's not... And I got really, really frustrated from doing that again and again and failing again and again. And, you know, I was following all of Microsoft's, you know, design patterns, all the best recommendations, building tiers and layers and tiers and distributing the layers. I even got to a point where I split my big application into multiple applications, yeah? So I had like this one application doing all the risk management, the other application doing all the stuff they're doing with finance, you know, charging credit cards and doing new stuff and so on. And another one to do all the customer-related stuff, and so on and so forth. And these applications were talking to each other using web services. Anybody done that here? Tried? Failed? No? So it failed miserably because once one of those applications failed, then all the other applications failed because they were all talking to each other. And when they failed, everything failed. It's just now like a huge failure. It's much more bombastic. It's instead of one thing failing, everything's failing. And you're running around between your servers and you're trying to figure out which one is alive and where does the problem start and so on. So you're distributing your problem and you're in the worst place. So I went to my master. Oops, I think I did something wrong here. So I went to my master, my favorite Yoda, and said, please, please tell me, what am I doing wrong? You know, I'm doing this thing again and again. I'm following all the best practices. I'm really, really frustrated. And I can't be the only crazy guy around, right? You know, Einstein said, if you try something again and again and accept a different... and you're doing the same thing again and again, and you're expecting a different result, you're probably crazy and stupid, or both. So Yoda said, coupling your problem is, and SOA should solve your problem. So what's this thing called service-oriented architecture? And what is it trying to solve? The biggest problem that when we build systems, the biggest problem we need to solve is coupling. It's this thing that we're building one component that talks to another component, whether it's a class or a physical thing, and that thing talks to another component, and they all have references, and when we try to start changing stuff, that's where things go really wrong, right? This coupling thing is what's killing us, because if we could just, in isolation, make a change and then go ahead and deploy the application, everything would be fine. You know, we don't really need to worry about it because we did the change that is going to change the way we do some business logic, like changing the user's name, and that's it. End of story. There is no, there's no repercussions. Everything is in, in isolation. It's nice and decoupled, and we would just go ahead and build another thing, and everything will work together, right? Obviously, this is not the way we build monoliths. So let's look at coupling. What is coupling? A fair and unfair coupling is the kind of what depends on you and what you depend on. And however you turn it around, there is no magic number. There's no, like, if you have 0 on one side and 2 on the other side, then that's good. If you have 5 and 3, it's going to be, if you have 42 and 0, that still is the same problem. So any kind of coupling is coupling, right? And you'll never end up with 0 coupling. So, obviously that's not the way to go. But of course, we want to reduce the amount of coupling that we have, so we get loose coupling less dependencies, more space, more ability to do change and to make things work. And of course, when we also need to scale, then this is the one important thing. Yeah? When we need to scale, it is not a problem. We don't hit the walls really quick. The aspects of coupling are three major kind of aspects of coupling. That the most important one is temporal. Temporal is this thing about time, right? If I call somebody on a phone, then at the stage that I call him, I ring him. I have to wait that he answers my call. We then have a discussion. There is an outcome, and we hang up. During all that time, both of us are tightly coupled to each other. So if I need to make a decision, and in order to make this decision, I need to call my boss, and I call him and he's not answering because he's in a meeting, I sit there and do nothing, right? I can't do anything. But when I get the data from him, I can go ahead and do some action, and then, I do that again and again, but we are coupled to each other, right? Because I have to get that information from the other side. That is a classic time-based temporal coupling. A good example that we all know from code is like a web service or a REST API or something that's calling another thing and we're expecting a reply. If you are expecting a reply, in the meantime, you're not doing something, right? You are waiting. That thread that goes in and does the call is now busy, and it's not going to be busy until you get a reply. Synchronous communication is all about that type of coupling, and it is everywhere. So if you call a REST API and you're waiting for a reply, not for the 200, but the reply, with data, then you're coupled. If you're calling a method that calls another method, that calls another method, and calls another method, and all that chain has to come back, you are coupled. At that stage, there is a thread that is totally coupled, totally designated to this call. The time that it takes for your dependencies to reply is the time that you're not active, that you can't do something else, right? And if that other thing is not there, then you're, excuse my language, you're screwed, right? You're sitting duck. You call and there's no reply, and you call and there's no reply. Special is more around deployment, things like where is my SQL server, where is my RESTful API, where is my base URL, my resource URI, and so on. Anybody wrote the SQL connection string in code here? Nobody. You're all saints, yeah? So I did it many times, initially anyway, and as soon as that somebody moves SQL Server around, you move your code, you deploy it on another server, everything breaks. So that's kind of a good example of a special coupling. Another example would be that when you develop, you have SQL Server and your app running in the same machine, everything's flying, right? As soon as you deploy it to production, that's actually that distance between your actual app and SQL Server brings a lot of issues with it. One of them would be, the latency that you get from the distance. And platform would be things that we're aware, I guess, a lot more aware today. When we get platform-specific stuff, trying to talk to other platform-specific stuff. Anybody did .NET remoting here? Complus? Stuff like that, yeah? So I share your pain. It was one of the more nice things to do in life. But those things, those kind of coupling aspects are really important to always keep in mind. Yeah, I mean, it won't go away if you don't think about it. It's not going to disappear because it's not there, right? But most importantly, it is the time-based synchronous communication coupling, because that's the most common one, and that's the easiest one to kind of ignore until you have a problem, right? So as I said before, the attempt, when you look at afferent coupling, try and do as least as possible, the least dependencies you have or dependence you have, the better it is. Obviously, you can't reach zero coupling. It's not going to work. You know, you always have something that you depend on, and you need it to run, and you need to have a connection string that is there and live. But do your best. Temporal coupling is one of the most common solutions today is asynchronous messaging. Yeah. What asynchronous messaging allows you is a fire and forget type of communication. Instead of going and saying, oh, I'm going to call this thing and get a reply and all that, I'm going to put a message on a queue, whether it's MSMQ, SQL Server, RabbitMQ, Azure Queues, whatever. You put a message on a queue, and that thing goes and gets processed by the consumer. It's asynchronous, as in, I don't get any reply. You might get a 200 from an API to say, hey, I got your request, and I'm going to put the message on the bus, but it is totally, you don't get any kind of data. I'll talk about the semantics of SQS later. And the other interesting thing is that you could use pub/sub, publish subscribe, which allows you to basically say, I'm interested in this event that occurred in your system. Please let me know whenever you charge the customer for an order, so I can go ahead and do my, send an invoice or something. Are these clouds? Jesus. So pub/sub is really useful when you kind of want to have things that don't talk to each other and not closely coupled at all, be able to get a notification. And I presume that all of you are here on Facebook or something similar to that, and you subscribe to those events that come from Facebook, right? And you get those notifications every 5 minutes that a friend just did something in whatever, or uploaded the thing, changed his status, liked your whatever, liked somebody else's, shared something, yeah? These are all pub/sub, yeah? So you subscribe to this feed, and that feed keeps on feeding you. And if you're a business application, you would do something about it. Or not. Special coupling is like simple solutions like that we all know today. We put the connection string in config file, or in a service locator in an agent. Anything that would allow us to remove those dependencies from our code and put them in something that we manage better. Platform coupling would be more, again, today we know those things very well with JSON and XML and HTTP protocols and all that. You know, we all use text-only simple protocols that don't include any kind of objects or any kind of things that are platform related. All these things kind of tie into the fallacies of distributed computing. And the fallacies of distributed computing have been written somewhere in the 90s by a guy, he coined it, I guess, or he kind of got the credit for it. It's Peter Deutsch. And he kind of observed that we are coding as if all these fallacies are true, okay? So I presume that most of us here done and do this kind of thing. Like we take a reference to a service, we create the object, the service, the proxy instance, and we go service dot get something, blah, 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 nice link statement behind it, and so on, right? Doing that, yeah? What happens when the service is down? Throw an exception. Log it. Okay. So we usually do nothing about it. We probably log it, and you know, the best scenarios that I've seen before is kind of a retry mechanism, which means that somebody actually thinks that this service might fail, but we don't. We don't think that, we don't code, and our code never looks like something that's going to fail. I better do some mitigation before I actually call this thing and make sure that I don't lose the data. It's usually like, oh, I'll just throw an exception. It will bubble up back to the UI. Somebody will take care of it. I log a thing, and the data is gone. So that $1 million order that was just in your pipeline has just disappeared forever, right? So that kind of relates to the network is reliable. If anybody thinks that I'm wrong, you know, that those fallacies are true, I really like to talk to them after the talk. Latency in zero. It all works very well when we develop on our local machine. It flies like nothing. As soon as you put it in production, latency kills you. Bandwidth is infinite. Obviously, today, with all mobile phones and all that, it is a lot more prevalent, and we all are more aware of it. But still, our code will not reflect that. The topology, the network is secure is the best, probably, yes. And we all assume that somebody else will take care of security, but otherwise the network is secure. There's no problems. We just later find that everything's really, really broken. Topology doesn't change, and whoever works with Azure or SQS, or Amazon or Google knows that, you know, the infrastructure changes every 5 minutes, 5 seconds. It all depends, but it's definitely not very stable. There's one administrator is like all about, you know, I'll throw it over the fence. The administrator will know what to do when the system crashes, and he goes to his Word document there and goes through the process to kind of figure out what went wrong, and he'll fix it. Transport costs are zero, and the network is homogeneous. These are just, you know, they should spark a question in your mind. There are 3 more kind of less documented fallacies, I guess, and they're put forward by Ted Neward. And one is that the system is monolithic or atomic. Yeah? And I think that today we're more and more kind of, we know that's not true, right? That we need to build distributed systems. The second one is the system is finished. Has anybody finished the system lately? So they went out of business, right? That's more or less it, right? I mean, if a business works, that you never ever finish the system. And the business logic should be centralized. Canon should be centralized. From a business perspective, it makes a lot of sense, yeah? Because businesses think like that. You know, if I want to check a business rule, I want to make sure that all my system is going to behave in the same way, right? But when you build a real system, you can't really do that, right? It doesn't really make sense, because if you centralize everything in one place, what do you have? Ideas? Single point of failure sounds, yeah? If you have a single point of failure, what happens? Everything goes down, right? Everything is going to be as quiet as you guys. You know, there's nothing. So I'm not going to really kind of dig in, because I don't have the time and the bandwidth to do it. I actually have about 5 minutes to finish this presentation, because you guys need to eat, and we started late. So there is a link here. We'll publish it on for you to download later. You can download a really nice book, and it explains in details the whole story. It's also a funny story, but the whole thing about the fallacies. So in practice, anybody love Karate Kid here? No? So in practice, you just have to do it, right? And instead of designing big things up front and all that, just do it, right? And the really important things that I'd really like to quickly go through are you have to kind of build your system. You have to kind of decompose your system instead of looking at it as a big, large system. Take every piece of functionality and build it into its own little autonomous thing. And instead of kind of building layers this way, build them vertically, okay? And use publish, subscribe, do your things explicitly, and use the single responsibility principle and command query separations and clean code. I'm running here, I'm sorry, I apologize, I'm really out of time, that's why I'm kind of quickly running through this, okay? This would be your classic monolith, where you have loose coupling in the tiers or layers that you build. This is the classic design. But you have very tight coupling between the different layers because they need each other. And once they need each other, they need the top, the ones in the top and the one in the bottom. To solve that, you use vertical slicing, which means that you take from the top to the bottom, including the database, you just slice and dice it. You just take all the functionality and put it into a single logical component that does this relatively small unit of work. Yeah. Remember that referential integrity cannot be, you cannot use referential integrity in a distributed system. So if you vertically slice only the business logic UI and a little bit more, the data access or whatever, you didn't slice and dice your data, you're going to be stuck in the same problem. Okay? So beware of that. So PubSub, an example of PubSub is if service A here receives a message to make customer preferred, he sends a command to service B. In the meantime, service A is waiting for a response, and when he gets a response, he's making customer preferred, right? That is the classical RPC, request response method. When you do it in PubSub, then you make customer preferred to service A, you send a command to service A. Service A stores the customer as preferred, and when service B has done any changes to this customer, he will publish an event to service A, and that data is going to be stored locally. Does that make sense? It's going to be available before. It's like being proactive about when do we need the data. A more concrete example, a sketch, would be that when sales starts up, it subscribes to the customer status update event. When customer care changes the status of a customer, it will publish an event saying the customer is changed, which sales is subscribed to, and it will save that state locally. The same for sales will subscribe to the product update, and when marketing is updating the price or something about the product, it will be, sales will receive an event and save the pricing locally. And now the customer comes in and puts an order in. Sales simply does its commands to marketing and customer care to say, order is accepted, and the whole thing flows. So there is this whole kind of reverse idea, yeah? Instead of when I need the data, I'm going to go and get it. No, when the data changes, when the state changes, when something meaningful happened in my system, I will subscribe to this event and know about it before I actually need to do anything. So to summarize, if you don't need to distribute and you're happy with your monolith, just walk away. Yeah, don't even bother doing. It's painful, it's hard, and it's complicated to do that other step. So if you don't need it, don't do it. But if you do it, don't use messaging and the patterns like CQRS and CQS, not CQS, CQRS and messaging and all that everywhere. Yeah, you use it when you need to use it, and do it well. Whatever you do, do it well. Don't, even if you just use the kind of the asynchronous thing in a corner in your system. I would advise to start off with your really small thing, like an email sender. Anyone has an email sender here in his app system? Just go, instead of that being a synchronous operation, just put there, send a message over to a component that would send your emails. Okay, really simple, really, really efficient, because instead of having the whole, synchronous thing waiting for the email server to answer, you just dispatch a message and that's it, yeah? That's a good example of where to start. And always, always, always remember to look at coupling when you're building something, because coupling is where the evil is, in a horrible way, I guess. If you want to do it on .NET, N-Service Bus is one of the tools. There are many other tools out there that will enable you to do infrastructure, give you the infrastructure for messaging. It's particularly .NET. And the most important thing, don't be afraid to fail, okay? Just do it, yeah? Just try and fail and say, yeah, all right, this one didn't work. I'll do it again, and just slowly learn and make it better, okay? Don't go building a whole system and a big thing and fail. Just do small things and fail quick and learn from them. I hope that it was pleasant for you guys to sit here for a couple of minutes. Thanks a million.